Assalamu alaikum everyone. My name is Sayyid Kazim Naqvi. My roll number is 29 and I'm a fourth semester student of Automotive Department of Punjab Tanjung University of Technology. So today I'll be presenting you about a fascinating topic that is metamaterials and its application in automotive industries. So we're going to see what are these materials, how they work and how they can help us in our automotive industries. Let's dive into it. So, what are these materials? To begin with, they do not occur naturally. We engineer them in our labs and we create them by changing its internal structure, not the composition. The composition doesn't matter in this type of thing. Their unique behavior depends upon its internal structure. So, when we have to get our desired properties that we cannot find in our naturally occurring elements, we go for the metamaterials and we synthesize them in a way that it can give us the desired result. So, what they do, they are designed to manipulate electromagnetic waves, sound, heat, or mechanical stress in a way that conventional materials, or you can say naturally occurring materials, do not do. So we synthesize them in a way to get our desired results, and we do that by changing its internal structure. So what are the key characteristics? So its characteristics, you can say, are very vast, but for the time being we will discuss a few of the main. So negative refractive index, it can give negative refractive index. What does this mean? It means that it can bend light or reverse the radar in a way that our normally occurring materials do not do. So sometimes when we work on metamaterials or we study about them, it's about hearing something from a science fiction movie, but it's not like that. They are very real. World is working on it, so the progress is quite fascinating. You're gonna see that how they can induce an effect on materials, how they can induce an effect on waves. So the second characteristics that we can see is sound and vibration manipulation. So it can block, absorb, or redirect sound and vibrations, for barriers. It can act as a barrier, it can act as a reflective surface for sounds, and this can help us in cars interior. So you get a comfortable and enjoying ride. You can get the sound, desired amount of sound at the desired amount of position by using these materials, and they're lightweight, and so you don't have that effect on cars acceleration, on mileage. So it's quite easy for someone to target sound to a specific location. And electromagnetic waves, it can control radars or light the advanced antennas. These metamaterials are also found in our mobile phones. The mobile phones have small antennas, so they use metamaterials for that. Go forward and see about what automotive industry needs. So fuel efficiency is, I think, is a major problem for this world, because we are uh, getting low on resources, fuel. We are converting our cars to EVs. So metamaterials can be used in EV range, so they can give you a good mileage. Fuel efficiency is can be quite increased as the car won't weigh too much, so you have a more lightweight car, and your engine won't have to drag it with so much force and use more oil or fuel, sorry. So it can give a good range of fuel, and it can also be used in EVs for good mileage. So ride comfort, it can impose ride comfort as by reducing noises from, as I said before, that it can manipulate sound waves. So it can create a barrier for the sound, for if you're inside a car and the outside or your surroundings is quite loud, if you're in a marketplace or the road. So if you're using metamaterials and your car is equipped with these type of materials, they can create a sound barrier for the person inside, so they don't have to hear much of the sound of from the outside. Then we have sensor performance. They're used in sensor as sensors performance can be increased by using metamaterials. So electromagnetic interference and heat. uh, we If you're in a car and you're driving, engine gets heated up. So though that heat doesn't approach the passengers, metamaterials are used in a way that it can block heat or absorb heat. Basically it can enable the car industry with futuristic design features and much more than what we can imagine now. So lightweight structures, its application, one of its application, lightweight structures. So metamaterials can replace the traditional metals and plastics that we use in our cars. And it's if it's not like we have low resources in this world, so naturally economic resources are growing low, and we need something else to give take us through this time. So we can use metamaterial that it's lightweight and it's strong, so the body panels can be made from them. And then if it the lightweight will preserve fuel. Going forward, we have acoustics and vibration control. Acoustic materials absorb and redirect cabin noise. So like I said before, if it's using in the interior of the vehicle, or you can say panels, body panels, or it can improve a passenger's riding experience by reducing the sound coming from the environment or from the you can, like, if you're listening to music in a car, you can direct the sound towards you in a way, like you can direct it to the seats, and you don't have to like listen to all the noises from the outside or from the car. If your car is making noises, it can uh, make your ride peaceful. You can use metamaterials to control the engine vibration, and your sound won't enter the car cabin. Just moving up. So sensors and antenna. So metamaterials also can be used in V2X communication, lidar, radar, and ultrasonic systems that we have in our uh, newly occurring or newly manufacturing cars. So what is V2X communication? V2X communication is like a vehicle to X, means like it's X as an variable. You can replace X with anything. V to VB हो सकता है, that means like vehicle to vehicle. V to I हो सकता है vehicle to infrastructure, which means like road barriers, road signs. So sensors will detect that type of information, and your car will behave in a way that your driving experience gets better. Or if you're in an autonomous vehicle, these type of things are very common, and these are very useful because you have to detect every road obstacle and every road sign to keep your car in the speed limit, or you have to stop for the signal. So these type of things are very important for an autonomous driving vehicle. Forward, we will see the thermal and EMI management. So as I said before, these materials manipulate waves, so heat waves are also a thing, and we use metamaterials in our EVs and other batteries to secure, as you have heard of the EV batteries getting heated up and catching fire. So metamaterials, if they are used in EVs, in cars like these, so they can keep you safe from a a hazard or an accident, that your car won't get caught up in a heating way. Or if you're in a like more compiled way, you can say that battery heat dissipation, your battery gets heated up. In IC engines, you have seen like battery is near to the engine. Sometimes it's in the trunk, but sometimes it's under the hood with the engine, so it can get heated up from the engine heat. So we can use metamaterials to secure the battery. EVs use batteries for with metamaterials, so get a more range and lifespan. To sum it up, metamaterials, you can say, in automotive world are offering new solutions in weight reduction, comfort, sensing, thermal management, and fuel efficiency, many more things. Like, these materials are being used in many things, and we can, uh, have a very convincing future for these type of things. Like, our vehicles can be very smarter, safer, and efficient by using metamaterials. It can be a key enabler for the vehicle transportation. Thank you so much for listening, and thank you so much for your time. Allah Hafiz.